Now, point capital G is 25 mm below HP and is situated in the third quadrant. Its shortest distance from the intersection of xy and x1y1 is 45 mm. Draw its projections and find its distance from VP. So here the point G is 25 mm below HP and is situated in the third quadrant. So obviously we have to take this third quadrant. Here, since he has not given any profile view, so we have, for the simplicity, we have taken the LPP as the point, which is left profile plane. So, and is situated in the third quadrant. Its shortest distance from the intersection of xy and x1y1 is 45 mm. So this is the xy line. So its shortest distance will going to be from here to here, which will going to be the shortest distance. But when you look from the left side view, the distance will be this one 45 mm. So because this is xy line, this is xy and also x1 y1 line, its shortest distance will be from here to here. So this is the distance. So draw the projections and find its distance from VP. So when you are looking from the front view, the distance below HP, which can be seen here, so which will going to be the 25 mm. So when it is projected, it will going to be seen on the vertical plane. So the distance between this point to this, that is behind LPP, the distance is not known. So he has not given any distance. So you can take whatever the distance you want. So that is the reason why we have written here it is any distance. So when you look from the left side view, we can see the distance below HP and also the distance behind VP. So that this distance can be seen here. But we don't know what is the distance with respect to this. But we know the distance below HP. So this below HP distance can be seen here. And also this shortest distance, which is from this point to the point in space, is the shortest distance, which is 45 mm, which can be seen here in the origin. So when this LPP is rotated left side and HP is rotated top, then what happens? So from this intersection line, you will going to get in this distance, it will be this now. Similarly, both G dash and G double dash in the same line. So since the distance is known, which is with respect to below HP, which is known, so naturally we can find out this G double dash distance, that is from here to here, which is 45 mm. So this is how we can analyze. Once we know this distance, so then what happens? The distance behind VP is this distance, which will going to be this, which will be automatically we will be going to get to this. So once you know the distance, when it is projected, this will going to be projected onto the top view, and hence we can be able to find out L is equal to what is the distance behind VP, that can be known. Now this is how we can analyze this problem in 3 dimension in the shortest distance in third quadrant. Now when we cut it here and then open horizontal plane to the top and LPP to the left side, so accordingly the images which are there in the respective planes will also be get rotated. So that means once the HP is rotated to the top view will going to become above xy line. The top view will become above xy line, and the side view will go to come on this side. So this should be small g and this should be G dash and this will be G double dash. Instead we have written P, but it should be G dash and G double dash. So now the distance with respect to the profile plane is not given, so we can take whatever the distance which we want and draw a vertical projector, and the distance below HP, which is 25 mm. So from here, from xy line you measure 25 mm. Because the image is on vertical plane, the image is below, since the vertical plane is below xy line. So from here you measure the distance of 25 mm below xy line and mark that point, and mark this point as G dash, and then draw a horizontal projector from the front view to the profile view, because once you look from the left side view, we can see the distance below HP in the profile view also. So since below HP, which is here, so you are projected directly onto the profile view, so naturally this distance is going to become below HP. But the distance, shortest distance from here to here is this distance, which is known now, and also G dash and G double dash both will going to be on the same line. So G dash is here, so when it is projected you will not be able to get the G double dash unless you cut the shortest distance from here to here. So by using the compass, take the radius of 45 mm with this as center, because he says the shortest distance from the intersection of xy and x1y1 is 45 mm. So So this will going to be the xy line and this will going to be the x1 y1 line. So then the shortest distance from here is from this point to this. So this distance is 45 mm. By using the compass, you measure a radius of 45 and cut an arc on the horizontal projector projected from the front view to the profile view, that is G dash. And once you get this point, you will going to get this point as G double dash, and you mark that point as G double dash. Then you project this vertically upwards, so that this will going to be the behind VP. So this behind VP, which is horizontal here, and this will going to be the below HP. So this below HP is vertical. So this distance, which is below behind VP, which is in horizontal direction, draw an angle at 45 degrees. Once you draw an angle at 45 degrees, this behind VP distance, which is horizontal, will going to become vertical. Then you project this point to the vertically projected point, vertically drawn projector from G dash in the front view to the top view, and where these two lines will going to intersect, will going to the point small g, which will going to be the distance of the point capital G behind VP. So the image what you get in HP is the top view, which will going to be small g. So measure the distance from here to here by using the scale, which will be L is equal to question mark. So this is how we can analyze the problem when the planes have been rotated by 90 degrees. Now we will going to solve this problem in the sketchbook by using the orthographic view. So here first you draw the xy line and the x1 y1 line, mark xy and x1 y1. Since he says it is in third quadrant, HP is above xy line, VP is below xy line, and this point will go to be LPP. It's not RPP, it should be LPP. Then the distance below H, so the distance with respect to the profile plane is not known, so you can take whatever the distance you want and then draw a vertical projector, and so mention this as any distance. Then the distance below HP can be seen in the vertical plane. The distance below HP, which is seen in VP, since VP is below xy line, from this point you measure 25 mm, mark this point, which will going to be G dash. Then draw a horizontal projector from G dash to the profile view, that is to the LPP. Then we know the shortest distance from the intersection of HP and VP is 45 mm. So with this as center, take the radius of 45 by using the compass, cut an arc on the horizontal projector drawn from the G dash to the profile view, where it will going to cut the horizontal line, will going to become G double dash. So this will going to be the side view. That means the front view and the side view both will going to be on the same line. So this is what G dash is here. When it is projected onto this, you are going to get G dash and G double dash both will going to be in the same line. When LPP is rotated by 90 degree, so these two are at 90 degree. When it is rotated, these two will going to become on the same line. So G double dash will, once you get the G double dash, so this will going to be below HP and this will be the in front of VP. So now in front of VP will be horizontal. So since it is horizontal, but in front of behind VP will be horizontal. So when you look from the in HP, so the behind VP will be vertical here. So this has to be found out. So we need to transfer this horizontal distance of behind VP into the vertical distance of behind VP. So draw a 45 degree line adjacent to HP. Then you project the vertical projector from G double dash to the 45 degree line. So you are going to get this point here. Once you get this point here, so naturally this horizontal distance, which is behind VP, will be transferred into vertical distance of behind VP. Then you project from the 45 degree line to the front top view, wherein it will going to intersect the projector drawn from the front view to the top view, so that this intersection point will going to be the point, the top view, where you write it as small g. Then by using the scale, you measure the distance from this point to small g, which will be capital L, which need to be found out. So here the answer is L is equal to 37 mm when you are doing it manual. If you are doing it in computer, it will be 37.42 mm. So then show the dimension here of 25 mm, which is below HP, and also the distance with respect to the profile plane. You can take whatever the distance you want and show this distance as any distance, and from the origin you take this as the radius 45 and then draw a 45 or 45, and then these are the directions of projection, wherein from G dash you draw a horizontal projector towards the LPP on the left side, and then from here you draw an upward projector to the 45 degree line, and then from 45 degree line to the top view draw a right side direction horizontal projector, where it will intersect the line drawn from the 45 degree line and also the vertical line drawn from G dash to the top view. Both will going to intersect at this point. This will going to become small g. So this will going to be the final sketch, final solution to be drawn in the sketchbook.